This would be homework 7.4. Some of you guys may have played around with this on IXL. One of those IXL logarithm lessons is so easy you don't actually have to know anything about them at all. But rewrite the equation into exponential form. This is your technique. Remember, log base b argument a equal to e as the inverse of b to the e equal to a. So I notice this lines up perfectly with this thing. That means that's my base, this is my answer, and this is my exponent. This is the easiest way to learn how to do logarithms, I swear it is. 6 to the negative second must be 136, and that is true because this right here is 1 over 6 squared. Whatever you write has to be true. So that's the answer. That's what all these are. I mean, when you get down to the next part, it literally says explain in words what the question is asking and then answer it. Remember, this is your base and this is your answer. All right? This is legit asking what power of 6 is 216? And the power is 3. A lot of teachers, when they teach exponents, they don't teach kids how to read they don't teach kids how to read logarithms. If you can read a logarithm, you can do a logarithm. It's that simple. This one, again, this is your base and this is your answer. It says what power of 1/4 is 16? You know, when I was your age, I probably would have done things like this. I probably would have typed in 1 over 4 and I would have pushed some buttons. It ain't cubed because that's 1 over 64. So then maybe I would have played with the negative exponents. You know, I know that if I flip it, I get positive 4, so I'm on to something. And there's your answer. The exponent of the power is the negative 2. This little section is mainly about learning how to rewrite logarithms. That's all it is. On 12 and 11 and 10, you can just push buttons. On 12 and 13, you have to use what's called change of base. So on your form quizzes, you probably have a log base b argument a is log a over log b, or natural log of a over natural log of b. It doesn't matter which one you push. So some kids like logarithms, some like natural log. It's really up to you. But if you do log base 5, then you're going to be log 42 over log 5. Or you can do the ln. You can do ln 42 over ln 40 of 5. And this is how I like it. That's me. I just think it's more elegant. So that's what I do. 4 decimal places. Surely it says that. 4 decimal places. 2.3652. And it does say, show the rewrite. Show it. Let's see, up here we have inverses. So find the inverse of the function. Write your final answer as after the negative first. And the first rule in writing inverses is to swap x and y. That's what we do. We swap x and y, and then we resolve. So I'm going to add 3. Now I'm going to identify pieces. This is my base, this is my exponent, and this is my argument. And what I'm doing is I'm thinking about log base b argument a equal to e is equivalent to b to the e equal to a. I'm actually looking at this rule from right to left. So I'm going to have a logarithm of base 2. Its argument is x plus 3, and that is y. And it's done, as long as I tell the person looking at my work that I did an inverse. All right, 17. At some point in time in your notes today, we wrote down that ln is understood log base e. So I'm going to put that little e there. All right. I'm going to perform step 1. X is log base e of y plus 1. And then I'm going to do the same thing I did on 15. This is my answer. This is my base. And sorry, this is my exponent. And this is my answer. So I'm going to be base e. I'm raised to the x, and I equal y plus 1. Shift over. E to the x, take away 1 is y, or f to the negative first power of x. Not that bad, but then again, I've been doing logarithms for a minute, so they're not that bad to me. I was supposed to do one of these. Huh. Okay, I'm going to do 19. Graph y equals 2 log base 5 x minus 4 plus 2. You're going to do this in a calculator, plain and simple. You are. You're going to be typing in, though, into y1, 2 log of x minus 4 over log of 5. And then you're going to add 2. Now, there are 2 transformations on here that are always going to stick around. That's an up 2, and that is a right 4. So I'm going to go ahead and draw those in. And the only issue with a calculator is they don't show you the truth. They do not show the truth because they can't compute numbers that small. They can't do it. Their calculators are tools. This is a logarithm. It ought to look like an R. I don't have the word logarithm written out, but logarithms look like R's. That's what they look like. And I am going to use the calculator for my table of values here. The centering here is not at 4. If you plug a 4 in here, this thing freaks out. You're going to plug in a 5, a 6, and a 7 because you can't throw a 4 at it. That should really be on this homework. I wonder why it's not. Anyways, we got a 2. I need to just type this math number. 2 logs x minus 4, sitting pretty over a log of 5, add a 2. And I'm going to look at the table first. See, I told you it'd freak out at 4. There's actually some good values you can get, like you can use 9. But anyways, 5 is 2, 2.86, 3.36. So 5 is 2. Oh, this needs to be fixed. See, this is vertical asymptote. I need to go back and fix this. 5 was 2, 6 was 2.86, and 7 was 3.36. From the table of values, all you get is that. From knowing what mom looks like, you know that she drops down and just runs really close to that vertical asymptote for all affinity. And I said again, the calculator doesn't show you the full picture. If you do a zoom 6, the calculator only draws to there. You cannot trust the graph on a calculator on certain functions, and this is one of them. The domain on this thing is from 4 to infinity. The range is going to be negative infinity to positive infinity, and the vertical asymptote is at x equals 4. That is the horizontal line or vertical line that cannot be crossed. I want to do 20, but I want to see if you can figure out. It's like really easy. 48. In the figure below, all line segments are either horizontal or vertical, and the dimensions given are in feet. What is the perimeter in feet of the figure? What? I go up 2. I go up 4. This must be 6. 2 plus 4 plus 6 plus 6 plus 8. Ta-da! What is that, 24? If C is directly proportional to S squared and C is 7/16 when S is a quarter, what is the value of S when C is 175? All right, so directly proportional is something that's just not in much standards anymore, but a directly proportional equation is written in the form of y equals some k x. In this case, it says C is directly proportional to S squared. So C is some constant times S squared. Now I know that C is 7/16 when S is a quarter. So I plug stuff in. This would be 7/16 equals 1/16 of K, which means that the K value is 7, because I multiplied by 7 for equality. So now that I have that, I have an equation. C is 7 times the quantity S squared. This is what is the value of S when C is 175. 175 is 7S squared. Divide out 7, I believe I get 25, and the S value is 5. Boy, those look a lot alike. So, bam. Bitty. If the value to the nearest thousandths of the cosine of alpha is negative 0.385, which of the following could be true about alpha? So this is interesting. Sooner or later, we'll talk hopefully about the unit circle. It's a unit circle. I marked 4 important radian measurements on it. I'll also introduce you to the acronym All Strippers Take Cash, or All Students Take Calculus, whichever one helps you remember it. The A says all ratios positive. The S says sine and cosecant positive. T is for tangent and cotangent positive. C is for cosine and secant positive. Here it's negative. It's negative. This means you're going to be in quadrant 2 or 3. Cosine to be, for the cosine ratio to be negative, you've got to be running where the x-axis runs backwards. So you're in either quadrant 2 or 3, which means you're stuck between pi over 2 and 3 pi over 2. But it does say which one of these could be true. And I don't see that answer. But I know it's pi over 2 less than alpha is greater than pi over 2, but less than 3 pi over 2. So let's see which one of these makes sense. F could be true. That's got that equality there. You can't actually equal pi over 2. Now, that's a very good distractor. Pi over 3 is over here. Pi over 6 is over here. 0 is right there. It's choice F. Because 2 pi over 3 is somewhere between pi over 2 and 3 pi over 2. 51, an integer from 10 through 99 inclusive is to be chosen at random. What is the possibility that the number of choices will have 0 and at least 1 digit? So inclusive means we include 10 and we include 99. Now, when you talk about probability, you talk about the sample outcome over what's called the sample space. You do 10 to 99, including the 10 and the 99, you do 99 minus 10, add 1 back. Sample space is 90. Now, how many of these guys have 0 as at least 1 digit? So your sample outcome is going to be 10, 20, 30, 40, 50, 60, 70, 80, 90. There happen to be 9 items in that list if I'm counting right, and I believe I am. So 9/90ths, which is 1/10. Choice B. And there is homework for 7/4. And I'm ahead of myself, which is good, because I'm sure when I come back, I'll have a crap load of stuff to grade, and I'll be behind again.